black holes, a mysterious cosmic enigma that both fascinates and frightens us, from the mind-bending properties of space-time to the unfathomable power of gravity. These celestial objects continue to captivate our imagination and inspire scientific inquiry. In this video, we will take you on a journey through the unknown as we explore what happens if a man goes inside a black hole. But before we begin our adventure into the unknown, hit like, subscribe, and ring the bell. It keeps the cosmos of content coming. With that, let's embark on this unforgettable journey. Albert Einstein's theories of relativity, both special and general, have revolutionized our understanding of the universe. His special theory of relativity, published in 1905, introduced the concept that the laws of physics are the same for all observers in uniform motion, and that the speed of light in a vacuum is constant. This theory had profound implications for our understanding of space and time, showing that they are intertwined in a four-dimensional continuum known as space-time. In 1915, Einstein further developed his theory of relativity with the publication of his general theory. This theory extended the special theory to include gravity and accelerated motion. According to general relativity, gravity is not a force, but rather a curvature in space-time caused by the presence of mass and energy. This theory has been supported by numerous observations and experiments, including the bending of light around massive objects and the gravitational lensing of distant galaxies. Einstein's theories of relativity have had a profound impact on our understanding of the universe and continue to be the foundation of modern cosmology. In 1916, German physicist Johannes Droste conducted research that laid the groundwork for our understanding of black holes. His work focused on the behavior of gas clouds near the surface of the Sun. By studying the motion of these gas clouds, Droste was able to calculate the gravitational field of the Sun and determine that there was a radius beyond which nothing, not even light, could escape the Sun's gravitational pull. This discovery was a crucial step towards understanding the concept of a black hole, an object so massive that its gravitational pull is strong enough to prevent anything from escaping its grasp. In 1916, German physicist Carl Schwarzschild further built upon Einstein's theories and calculated the radius of this point of no return, now known as the event horizon of a black hole. Indian astrophysicist Subramaniam Chandrasekhar determined the minimum mass required for a star to collapse into a black hole. Their research provided a deeper understanding of the conditions under which a star must exist for it to become a black hole after it runs out of nuclear fuel. These scientists' contributions were instrumental in advancing our knowledge of black holes and their properties, laying the foundation for future discoveries and exploration of these enigmatic celestial objects. The term black hole was first used in print in 1964 in an article in a magazine. However, it was not until 1967 that the term gained popularity in scientific circles thanks to the efforts of physicist John Archibald Wheeler. At a conference in New Delhi, Wheeler used the term black hole to describe a collapsed star that is invisible due to its intense gravity. The term stuck and soon became the preferred way to refer to these mysterious celestial objects. Since then, the term black hole has become synonymous with these fascinating astronomical phenomena and continues to be widely used today. There are different types of black holes. Stellar mass black holes from star collapse, intermediate black holes, supermassive black holes, millions to billions of times the Sun's mass, lurking in the centers of galaxies, and possibly primordial black holes formed just after the Big Bang. They're invisible, but not undetectable. Their immense gravity pulls in gas and light, creating a glowing disk around them. The accretion disk, the largest black hole ever discovered, is named Phoenix and has a mass of more than 1 trillion suns. Despite their enormous mass, black holes are incredibly dense. A teaspoon of matter from a black hole would weigh billions of tons. This extreme density is what gives black holes their immense gravitational pull. How does a star's mass affect the formation of a black hole? When a star's mass increases, the pressure and temperature at its core also rise. As the star begins to run out of nuclear fuel, the balance between these forces is disrupted and the star collapses. The greater the mass of the star, the more massive the black hole formed during the collapse. For example, if a star has a mass of 10 times that of our Sun, it will form a black hole with a mass of approximately 20 times that of our Sun. Conversely, if a star has a mass of half that of our Sun, the resulting black hole will have a mass of about 1.4 times that of our Sun. This relationship between a star's mass and the resulting black hole's mass highlights the incredible power of gravity and the extreme conditions that exist in space. What is the difference between a neutron star and a black hole? Both neutron stars and black holes are formed from the remnants of a star's core after it collapses. However, the process by which this occurs differs significantly depending on the star's mass. When a low 2-medium mass star, roughly up to 20 times the mass of our Sun, runs out of nuclear fuel, the core collapses, forming a neutron star. In contrast, when a massive star, much larger than 20 solar masses, exhausts its nuclear fuel, the core collapses to form a black hole. This difference in mass determines whether a neutron star or a black hole is formed. Why can our Sun not become a black hole? Our Sun is a medium-sized star and will not become a black hole after it runs out of nuclear fuel. This is because our Sun simply does not have enough mass to overcome the quantum effects that resist gravitational collapse. After our Sun exhausts its nuclear fuel, it will expand into a red giant, engulfing the inner planets, including Earth. Eventually, the outer layers of the Sun will be thrown into space, leaving behind a white dwarf. This is a small, dense remnant that is the final stage of stellar evolution for stars like our Sun. What if a man goes inside a black hole? If a person were to fall into a black hole, they would be met with a terrifying sight. As they approach the event horizon, the edge of the black hole, they would see the sky turn black and stars twist and distort until they become unrecognizable. The person would feel the intense gravitational pull of the black hole, stretching their body in all directions. As they cross the event horizon, they would be pulled towards the center of the black hole at an ever-increasing speed. At this point, there would be no escape. The person would be completely trapped inside the black hole and would eventually be crushed and pulled apart by its immense gravity. On April 10, 2019, the Event Horizon Telescope released the first-ever image of a black hole's event horizon. The image showed the glowing gas and dust swirling around the edge of a supermassive black hole located in the center of the M87 galaxy. The EHT is a global collaboration of researchers who use radio telescopes around the world to observe black holes. The image was captured using 7 radio telescopes on 4 continents and was processed using advanced imaging techniques. It marked a significant milestone in astronomy and provided valuable insights into the nature of black holes and their role in the universe. In April 2024, the star-tracking space telescope Gaia discovered its third black hole. The black hole, known as BH3, is the second closest to Earth at just 2,000 light-years away. The discovery was made using data from Gaia's second data release, which contains information on more than 30 billion stars in the Milky Way. BH3 is a single black hole with a mass about 10 times that of our Sun. It is also a bit of a monster, having consumed several dozen stars over the course of its lifetime. The discovery of BH3 was made possible by Gaia's unprecedented measurement capabilities. The spacecraft is equipped with a 1.5 billion pixel camera that allows it to measure the positions, distances and motions of stars in the galaxy with incredible accuracy. Proof of the existence of a black hole. One way to prove the existence of a black hole is to observe its gravitational effects on nearby matter. For example, astronomers can measure the speed of stars near a suspected black hole and use this information to calculate its mass. If the mass is found to exceed the maximum possible mass of a neutron star, then it must be a black hole. Additionally, black holes can be detected by observing the light from objects as they pass behind the black hole and get distorted due to gravitational lensing. Gravitational lensing can also be used to detect the presence of a black hole. When light from a distant source passes near a massive object, such as a black hole, it is bent and distorted, creating a magnified and distorted image of the source. By observing this distortion, astronomers can infer the presence of a black hole. How dangerous is a black hole to our universe? While black holes can pose a threat to anything that ventures too close, they are not inherently dangerous to the entire universe. In fact, they play a crucial role in the formation and evolution of galaxies. Most galaxies, including our own Milky Way, have a supermassive black hole at their center. These black holes provide a gravitational anchor that helps to stabilize the galaxy and regulate star formation. Additionally, black holes are not all-consuming and do not actively seek out matter to consume. They only pose a threat to objects that come within their gravitational reach. Therefore, as long as we remain far enough away from black holes, they should not pose a danger to our universe. As we conclude our journey into the enigmatic world of black holes, we hope you have learned something new and exciting about these fascinating celestial objects. And join us on our future adventures as we continue to explore the mysteries of the cosmos. Thank you for watching and keep looking up.